So in a previous lecture, we have calculated the angular momentum by using the Lagrangian equation of a motion in a central force field. Okay, so what we have calculated is L is equal to mr square theta dot, and from this equation I can write that this theta dot is equal to L upon mr square. Then by using the same equations, let us try to calculate initial position vector R in a central force field. Okay, so for that, let us write the equation T plus V is equal to E, where T is the kinetic energy, V is the potential energy, and E is the total energy of the system. We know that T is equal to M R dot square plus R square theta dot square, which we have already calculated in our previous lectures, plus V is equal to E. Now let us put the value of this theta dot, which is angular displacement and which we have calculated from the second Lagrangian equation of a motion. So I can write that 1/2 m r dot square plus m r square multiplied by L square upon m square r raised to 4 plus V is equal to E. So this m and this m square will get cancelled. This r square and 2r out of this will get cancelled. So the remaining term will be m r dot square plus L square upon m r square plus V is equal to E. Now as I want to calculate the position vector, I will take this 1/2 m r dot square on the left hand side, and the right hand side remaining will be E minus V minus L square upon mr square. I want the value of this r dot, so r dot square is equal to 2 by m E minus V minus L square upon mr square. And if I want to calculate the value of r dot, right hand side will be square root of this all term, 2 by m E minus V minus L square upon mr square. As we know that r dot is nothing but dr by dt, which is equal to whole this term 2 by m E minus V minus L square upon mr square. Okay, so I can write this dr is equal to square root of this whole term multiplied by this dt. So once I know the remaining terms from by using this equation, I can calculate the position vector r by using this Lagrangian equation of motion. So this is one of the physical significance of the Lagrangian equations of motion in a central force field.